Guys, welcome to today's physics class. So today we are going to be talking on equations of uniformly accelerated motion. So first thing, you have to know the three equations of motion. What are the three mostly used equations of uniformly accelerated motion? The first one is v equals to u plus at. This is the first one. The second one is s equals to ut plus half at squared. V squared equals to u squared plus 2as. So this is equation 1, this is equation 2, this is equation 3, where v equals to final velocity. Yes, v is a symbol for final velocity, u is a symbol for initial velocity, a is acceleration, t is time, s is distance. I hope that's all here. V U A T S. So these are the three equations of motion. So now, what did our question say? Our question said a car moves from rest with an acceleration of 2 meters per second squared. 2 meters per second squared. Find its velocity when it has moved a distance of 50 meters. So we are going to show them the givens. Yes, we are going to write out the givens. What are the givens? From the question, a car moves from rest. And note, if a car moves from rest, the initial velocity is going to be 0 because it's moving from rest. The initial velocity, the velocity it used to start moving, is going to be 0. So initial velocity is what? U equals to 0. Now, what are we given again? With an acceleration of 2 meters per second squared. Acceleration equals to 2 meters per second squared. Find its velocity. Velocity is the problem. Yes, you analyze physics when solving to make it easier when you're solving it. A lot of students find difficulties in physics, thinking it's a hard subject, but physics is one of the simplest subjects. So let's move on. Find its velocity. Velocity is the problem when it has moved a distance of 50 meters. Distance is s. S equals 50 meters. So now, what next are you going to do? Look for the equation of motion that contains these givens. Let's try equation 1. Equation 1 says u, we are having u, a, no time. Equation 1 can never work in this situation. Let's move to equation 2. U is there, a is there, time. We are not given the time. Equation 2 cannot work in this situation. What about equation 3? U is there, 2 is just a constant, s, a, v. You see, this equation 2 works best. So you write from equation 2, v squared equals u squared plus 2as. V is the problem. So v squared equals u squared. U is 0, so is 0 all squared. You substitute the values. 2 multiplied by what is acceleration? 2 multiplied by what is the distance? 50. Yes, 50. So you continue, the space cannot contain. You continue on the next page. Don't worry about me. So continue on the next page. So we have v squared equals 0 squared is 0 plus 2. Let's go back to the previous distance. 2 multiplied by 2 is 4. Multiplied by 50 is 200. So here we are going to have 200. So v squared equals 200 plus 0 is 200. Now, some students might think this is the final answer. No, this is not the final answer. So you take the square root of v of both sides. So square root of v squared is equals to the square root of 200. So square roots cancel this square. So v equals to root 200. 200 is not a perfect square. So I think we can apply law of surd in this place. So v equals 200 return to 100 multiplied by 2, because 100 multiplied by 2 is still 200, and 100 can be taking the square root of. You can take the square root of 100. So v equals to square root of 100 is 10 root 2. So this is our final. This is not our final answer. We are going to add the unit of velocity. Velocity is measured in meter per second. So therefore, the velocity when the car has moved a distance of 50 meter is 10 root 2 meter per second. Thank you.